Hello everyone. Today we're going to learn about complete and net ionic equations. A quick review of some information about solutions that is relevant to what we will be discussing. A solution is a homogeneous mixture in which a solute dissolves into a solvent. When the solvent is water, the solution is called an aqueous solution, with that aqua prefix implying something about water. When solutes dissolve in water, one of two behaviors is observed. Either the solute will behave as an electrolyte or a non-electrolyte. An electrolyte is a solute that when it dissolves in water, it breaks up into pieces. Specifically, those pieces are ions. In the image here on the right, you'll see that sodium chloride has dissolved in water and broken up into sodium ions and chloride ions. A non-electrolyte is a solute that when it dissolves in water will stay together as its whole molecular self. Think something like glucose. When an ionic salt dissolves in water, it undergoes dissolution, which can be represented by a chemical equation. For example, if I were to write the equation for the dissolution of calcium chloride, it would be that calcium chloride yields a calcium 2 ion and 2 chloride ions. If we look at the salt, we see that I see 1 calcium is present and 2 chlorides are present. So therefore I have 1 calcium ion and 2 chloride ions. They also have been assigned to their respective charges because they're now written in their ion forms, and they are assigned aqueous on the product side because they are dissolved in water on the product side. Let's do another example of a dissolution equation. Write the equation for the dissolution of lead 2 nitrate into water. Reminder, you should identify who the cation and anion are. Ideally, you may also want to identify their charges at this time. Also identify how many of each of them are present. In the formula for lead 2 nitrate, lead 2 and nitrate are the two ions that are present, with lead 2 being the cation and nitrate being the anion. There is only one lead 2 in this formula, and there are 2 of the nitrate group, represented by the 2 that is outside the parentheses. And so we'll be representing 1 lead ion and 2 nitrite ions being formed when lead 2 nitrate dissolves. So the equation for the dissolution of lead 2 nitrate would be solid lead 2 nitrate becomes 1 lead 2 ion that is dissolved in water, it is aqueous, and 2 aqueous nitrate ions. You'll notice, once again, the charges and the aqueous state are included for the products. A quick review of some information about single and double replacement reactions. Both single and double replacement reactions that we have been learning about in this class occur in aqueous solution and, generally speaking, involve one or more ionic salts. Therefore, the reactants and products for a single or double replacement reaction could be rewritten so that the ionic salts are broken into their ion forms to represent that they have dissolved and broken into pieces. So let us try this. Example, rewrite the equation for the following chemical reaction with all of the aqueous salts that are present broken up into their ion state. Please note that I do specify aqueous salts. There is one salt here that will not be broken up because it is not aqueous. Let's take a look at the first one. We have that there are 2 silver nitrate aqueous present. Within the individual formula, I see 1 silver and 1 nitrate. However, that coefficient of 2 applies to that whole molecule. And so, if I rewrite this so that I've just broken up the first one so you can see what we are doing, there are 2 silver ions present in the chemical equation and 2 nitrate ions present in the chemical equation. We will then complete the breakup of the others, the calcium chloride and the calcium nitrate. So now I have completed the breaking up of the process, and for the final answer for this, I get 2 silver ions and 2 nitrate ions, and 2 calcium ions, and, 1 calcium 2 ion, sorry about that, and 2 chloride ions yields 2 silver chlorides solid, a calcium 2 ion, and 2 nitrate ions. You'll notice there are some ions that are repeated on both the product and reactant side. This is normal, considering the same ions are generally present on the reactant and product side, just swapped places for a double replacement reaction like this. What we just saw on the previous screen is an example of a total or complete ionic equation. In a total ionic equation, all of the aqueous salts have been broken up into their ion forms. And, generally speaking, there are ions that are present on both sides of the reaction that are repetitive. For example, in the previous one, we saw calcium 2 ions and 2 nitrate ions present on both sides. This is okay and is actually very normal for a total ionic equation. However, there is a version of the ionic equation that won't have these present. This version is called the net ionic equation. The net ionic equation is a, quote, simplified chemical equation where the spectator ions have been removed. Spectator ions are ions who do not participate in the chemical reaction, and therefore they do not change over the course of the reaction. Basically, they are simply there and observing, but are not changing. In a total ionic equation, they are present in both the same number and in the same state on both sides of the chemical equation. So if you had 2 aqueous nitrates on the reactant side, you would need 2 aqueous nitrates on the product side to qualify as a reactant. Alkali metal cations like sodium and potassium, as well as all other ions that are frequently soluble, are very common spectator ions. So keep an eye out for those who are frequently soluble. They are very likely to be spectator ions, although not always. Let's do an example of writing a net ionic equation, and let's use the equation that we already wrote the total ionic equation for previously. So we're going to write the net ionic equation for the reaction between silver nitrate and calcium chloride. Previously, we determined its total ionic equation is 2 silver and 2 nitrate, and 1 calcium and 2 chloride yield 2 silver chloride and 1 calcium and 2 nitrates. There are spectator ions currently present. They are the 2 nitrates that were present on both sides and the 2 calcium ions that are present on both sides. Since they are present on both sides of the equation, what do you think we should do with them? Like we would in math, when I see 2 things on the same side of the equation, I can cancel them. So we are going to cancel them and then rewrite what remains to create our net ionic equation. So you'll see here in line 2, I have canceled out the 2 nitrates because they match on both sides, and the calcium ion because it also matches on both sides. The only things I have not touched and that don't have an equivalent are the 2 silver ions, the 2 chloride ions, and the 2 silver chlorides. So I will rewrite these, and the final step on this screen here, where I've rewritten it and cleaned it up, is the net ionic equation. The main thing that occurs in this reaction is the 2 silver ions and 2 chloride ions react to form 2 silver chlorides. The general procedure for writing a net ionic equation has been demonstrated for you, but I would like to have it written out so that you can have a step-by-step that you can think of. First, you need to have a balanced chemical equation. So you'll need to locate it, create it, or just simply have it given to you. Step 2, write the total ionic equation. Break up all the aqueous salts that you can and write it out so that you can see where your spectators might be. Step 3, cancel out those spectator ions that you see. And then step 4, rewrite the remaining pieces that are still there, which will generally be ions and a solid salt of some sort, or maybe some other molecules or atoms if it's single replacement, in order to create a net ionic equation. You can do this for both double and single replacement reactions. All the previous examples were with double, but single can also be done, in which case there is usually only 1 spectator ion. You may eventually get to a point where you will no longer need to write the in-between steps of step 2 and 3 out before you can create the net ionic equation. If you are not there yet, that is okay. Take time and eventually you might get there. All right, good luck everybody.